You noticed from the beginning of last week till yesterday, I don't know if some of you actually paid attention to the standard. Most of the standards that I flashed up there, they had a little 7 right here. It should have said 7 CCSS, which is Common Core State Standards. But from this point forward, now we're just going to focus on algebra standards, geometry standards, and algebra 2 standards. So it should say at least 8 Common Core State Standards. Does that make sense? So today we're going to start focusing ourselves on exponents. But the second standard that I want us to focus on, which is this one, Math Practice Standard number 6, which is attend to precision. What does that mean? That when I ask you to participate or give me an answer, be as accurate as possible. And I'm not just talking about with numbers. I'm talking about with vocabulary. And when I ask you for a definition, try and kind of like think more as a mathematician. Does that make sense? All right. So instead of saying, well, what I think we should do, try to, instead of bird walking like that, just go straight to the point. When doing this, we need to do this. Be more precise. Okay? So with that said, our objective for today, can you read that for us, Nate? Thank you. It says, I can simplify exponential expressions using the multiplication properties of exponents. Everybody on 3? 1, 2, 3. I can simplify. Good. So what goes in the Freire model, in the middle of this Freire model? Exponential expression. So write that in there, please, and write your objective at the bottom left. Bless you. Now, this lesson's going to go pretty fast, so everybody go like this. Look up. Go like this. So you can bear with me. Bear. I did? What did I write? Popper cheese? I didn't write the R? No. Wow, Paulina, be nice. Wow. Okay, I'll change it. Thank you. All right, so we got this. Exponential expressions, what are they? Exponential expressions are a numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. Exponential expressions, a numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. Exponential expressions, a numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. A numerical or variable expression raised to a power greater than 1. So you know the definition for exponential expressions? Examples, write these down, please. 2 to the 3rd power, x to the 6th power, negative 3x to the 4th power, x squared y cubed. Copy that. All right, let's look at the definition. It says, a numerical or variable expression. Okay, let's look at this first one. Look up. What kind of expression is this? Numerical, because it only has numbers. Is it raised to a power greater than 1? Yes. What kind of expression is this? Variable, raised to a power greater than 1? Yes. This is a tricky one right here. What is this one? Numerical. It has numbers, but as soon as it has a variable, it remains a variable expression. Okay? Who thought about that one? Yeah, good. All right. How about this one? Variable. Okay. So now we know what they look like. We know what they are. Let me show you what they are not. Copy those. As you're copying those, start thinking, if these are exponential expressions, then why are these not exponential expressions? Talk it over with your neighbor. Why are these not exponential expressions? All right. Let's start with this one right here. Jaylene, why is that not an exponential expression? Because it's an equation. Does everybody see that? Okay, pass someone. Jesse, how about this one? Why is this not an exponential expression? Because it's an equation. Bam. Pass it someone. Who? Roman? Or who? Aguirre? Okay. Roman. Why is that not an exponential expression? Yeah. Okay, that's one thing. It could be one thing. But read the definition again. And look at that non-exempt. Did everybody hear that? It has an invisible 1 exponent, but it doesn't have anything greater than 1. So yeah. All right? So now I want you to come up with some hashtags. Exponential expressions are hashtag what? Come up with at least 2 or 3. Exponential expressions are hashtag what? All right, start us off, please, Melanie. Hashtag. Bam, no equal sign. Pass someone. Maria. Hashtag exponents. Pass it someone. Stephanie. Hashtag greater than 1. Greater than 1 what? What has to be greater than 1? Exponent. Okay. And then you have some other ones, but you keep those. Yes? How are we doing? Fairly simple? All right. So underneath your FAIR model, I want you to write steps. Write these down, please. It's only 4 simple steps. Step 1, identify if the exponential expression is a product of powers, power of power, or power of products. Use the appropriate property to compute. And number 3, simplify. 3 simple steps. Identify if the exponential expression is a product of power, 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 products. Step 2, use the appropriate property to compute. Step 3, simplify. Oh, BTW, why don't we write solve for step 3? Everyone, why don't we write solve for step 3? They're not equations. Bam. They're not equations. Copy that, please. All right. So for the purpose of continuing with this concept, just remember whenever they say powers, they're referring sometimes just to the exponent, or they also refer to the actual exponential expression as a power. Okay? So therefore, Remember yesterday that we went over a problem from the home plate where we used the additive inverse property? And I said the name of the property tells you what to do. Additive means to add. Inverse means the opposite, right? So look at this term right here. Now, when you first read it, it didn't really mean that much to you because you just wrote it down and, okay, we're going to cover that. But if you slow down and read it again, you should know exactly what we're going to do with that property. Look at this one. Product of powers. Think about it. Product of powers. What does the word product imply? Multiplication, right? Answer to a multiplication, okay, multiplication. Powers, an exponential expression, right? So what do you think we're going to be doing for product of powers? Multiplying two exponential expressions. Does that make sense? So whenever I give you terminology, try and see if you can make sense as to what we're going to be doing with that property, okay? Things to remember. Writing utensils down, look up to the screen. For the purpose of introducing these properties, focus please, I am going to be using numbers or variables without an exponent. But whenever I give you something like that, like this, a number without an exponent, I want you to rewrite it with an exponent of 1. Is everybody understanding? Look at this one. If I give you a variable, you're going to write it also with an exponent of. If I give you a negative number, you're also going to write it with an exponent of. So anytime I give you something that does not have an exponent, what are you going to write? A 1. Everybody got it? Also, I'm going to revisit these two properties that you were introduced to since elementary. I'm assuming 3rd grade, some of you 4th grade. Commutative property of multiplication, associative property of multiplication. Now, once again, the property itself should tell you what to do. You just need to understand the words. Let me read the first one. Commutative property of multiplication. So it involves multiplication. That's an obvious thing. Commutative. Commutative comes from the word commute. Let me use it in a sentence so you remember what it means. Some of you might know. There's some teachers at Frank Wright that commute every day back and forth from Yuma. So what does the word commute mean? Switch, or move, or travel. Does that make sense? That's what commute means. Therefore, look at the property, commutative property of multiplication. That means it's going to involve numbers, and numbers that do what? Switch and move. So check this out. Let me show you what it means. If I gave you 2 times 5 times 4, and we applied the commutative property, which numbers do you want me to move around? 2 and 5? Okay, so if I move this one here and this one here, they commute, and now the new expression is 5 times 2 times 4. Did numbers move? Yes. So now what the property states, it doesn't matter how you move them, the product is the same. Let's see. What is 2 times 5? Times 4? 40. What is 5 times 2? Times 4. So it doesn't matter which way you arrange them, the product is the same. Fairly simple. Let's go to the next property, associative property of multiplication. Again, multiplication, we got it. Associative comes from the word associate. And you guys are experts at that, right? You guys associate yourselves with a group of people. Now, let me give you an example that I've seen elsewhere, not here. Here it goes. There's 3 friends, 2, 5, and 4. They're hanging out. But then all of a sudden, they get mad at one of them. And 2 of them associate together and leave the other one out. But like it happens always, after a while, one of these 2 gets upset at the other. You still have the same 3 friends. However, now, instead of these 2 hanging out, these 2 hang out. Did the order change? 254, 254? No. What is the only thing that changed? How they associate, right? So what the property states, it doesn't matter how you associate it. If there's multiplication involved, the product is the same. What is 2 times 5? 10 times 4? 40. What is 5 times 4? Times 2? Did it change? No. Everybody understand those properties? Because we're going to be using those, aside from the new property that we're going to learn. So here we go. On the Q column, you see your Q column on your Cornell note? Everybody know what the Q column is? All right. On that column, I want you to copy commutative property of multiplication, copy these examples, and associative property of multiplication, and copy this example. Copy that, please. All right. So, in the back, you wrote product of powers property. Yes? It's up there? So, I'm going to go over the property so you guys can see how it works. But once again, I'm going to be quiet. You're going to do all the thinking. Then you're going to talk it out with your neighbor. And you need to come up with a definition for the property. Yes? Here we go. Example Q. Writing utensils down, eyes up here. So I'm going to first write what we're going to use, and then I'll use the property so you can see how it goes to work. Yes? Okay, writing utensils down. Here it goes. And then, of course, I'm going to use algebra also. All right. Before I use the property, what is the first thing I asked you to do before I get started? Put a 1 on everything that does not have an exponent. All right. Now that I have that, here goes a property. Once again, writing utensils down, look up to the screen, let your noodle do all the work. Here it goes. Okay, and just to clarify, 2 to the 3rd times 3 to the 7th. Talk it over with your neighbor, see what's going on with that property. See what the rule is. What is the rule? Okay, copy that, please, and then we'll get started with our definition. Once you copy those examples, underneath I want you to write an asterisk and a heart, so that we won't forget our definition for that property. Copy that. All right. So as you're finishing up writing that down, you talk it over with your neighbor. You already know what the rule does. So let me get you started with the definition. When what? What are we doing here all the way through? What are we doing? Guys, what are we doing? Yeah. Okay, so that is the rule. But what is it that we're doing overall? When multiplying, what? What are we multiplying? Pass someone? Daniel? What are we multiplying? What are these called? Are we multiplying exponents? No. So what are we multiplying? What are these called? They have a specific name. Jaden? Exponential expressions. Exponential expressions. When multiplying exponential expressions, we what? Yeah. If the base is the same, we keep the base and add the exponents. Does that make sense? Let me read it again completely. When multiplying exponential expressions, okay, kind of sounds kind of weird, so if I was to take the we off, if the base is the same, we keep the base, okay, and add the exponents. Does that make sense? Yeah? All right. And at the end, just write 10q. Did you ever see that? 10q. 10q. No? 10q. Yeah? Tell your neighbor what it means. Be nice. Example super Q. Copy this down. For tonight's home play, you're going to get some of these. 2 to the third times x to the fifth times 2 times x to the sixth. So everyone, what is the first thing we do? Put a 1 as the exponent for the 2. Is that correct? Okay. Now check this out. This is the kind of work I want to see tonight. Look up to the screen. Multiplication all the way through, yes? However, which ones are the same base? This one and this one. So can I move stuff around? Yes. 2 to the third, and that's an ugly 2. 2 to the third times 2 to the first. Are these the same base? Times x to the fifth times x to the sixth. Did I move stuff around? Tell your neighbor what property that is. That is correct. Commutative property of multiplication. That is correct. Now, after that, since we're not done simplifying, look what I'm going to do. So this becomes 2 to the fourth and x to the 11th. What property did I use to do the next step? Everyone. That is correct. Associative property of multiplication. Now, for the home plate for tonight, if you have a small base, that is 1, 2, or 3, and the exponent is less than 5, I want you to multiply it out and simplify it a little bit more. So this one is 2 to the 4th. Yes? What is 2 times 2? Times 2? Times 2? So this becomes 16x to the 11th. And this is already simplified. This is what I want to see. Does everybody see? See? Okay, good. Example, mega Q. Do this one by yourself. A to the 3rd times A to the 7th times A to the negative 8. Should be almost done. So, are all these the same base? So we keep the base. And what do we do to the exponents? You guys said add the exponents. What is 3 plus 7? Plus negative 8? 2. Hands if you got A to the 2nd. All right, good. Here goes another one. Example, Shazam Q. 3 times y to the 2nd times 3 to the 2nd times y to the, give me a number, 10. Do that one by yourself. See what you get. See if you can do that one like the one we did for example super cube. Share with your neighbor, see what they got. Answer. Who haven't we called on in a while? Who? Jerry, what'd you get for Shazam Q? Maria, help him up. Hands if you got 27, white 12. That is correct. Some of you left it as 3 to the 3rd, y to the 12th, but like I said, try and multiply it out. Yes? All right, home plate for tonight. Get a blank sheet of paper out, please. It's only 10 problems. Numbers 1, 2, 3, 4, 5, and 6 are up here. However, numbers 7 through 10, you're going to make up. So you make up your own for those 4. But the rest are up here. And also the video is going to be uploaded at the end of the day. So if you want to visit the channel and just go from there. As soon as you're done copying, have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.